All right, so now that we've talked about the sum and difference identities, we're going to go to example one where they said, first off, to produce a counterexample of this. So in other words, show where this would not be true. And then it says, show the sum identity for cosine is true for the values used in part A. So in other words, whatever we use in part A to show that that's not true, use the same x and y values in part B to make that true and show that it is true, that it works for the sum identity. All right, so starting off with A, and again we're trying to do a counterexample. So in other words, making this both sides not equal each other, because if they don't equal each other, that's not a identity, and that's what we're trying to prove. Okay, so let's just choose, let's say let x equal pi over 3 and y equal pi over 6. Now with these, you should remember the values from, you should remember the values from the unit circle. So this shouldn't be something that's hard or can't remember how to do. So we're substituting the values in for x and y. Over here, so that the cosine pi over 3, plus cosine pi over 6. All right, so those, you should remember the values already of what they are. So if you remember the values of what they are, you should be able to get that done quickly, right? And first off, we already know that they are in the first quadrant, so that everything's positive on this side. So the cosine, and actually this side would be positive also. But here, this would be positive 1/2. This would be positive square root of 3 over 2. And now if you ask me, wait, where'd you get that from? I'm so confused. Remember what cosine pi over 3 is using our unit circle. And that was 1/2. So don't forget those things. We need to remember those. All right, so then I'm going to combine these on this right side. And remember, if they have a common denominator, you just combine them and make it to one fraction, which we talked about that when it came to our identities, our basic ones so far. The ones we talked, the 3 identities we've done before to simplify and expressions and to verify identities. All right, so then the other part here, if we combine these two, so I'm going to first off do this. Now again, we can't combine these two fractions. Why? Because they don't have a common denominator. In between 3 and 6, your common denominator is 6. That's your common one. So we can multiply this by 2 to get 6, multiply this by 2, and that gives us 2 pi. 2 pi. So here, the cosine 2 pi over 6 plus pi over 6. If we combine those, that's 3 pi over 6, or 1/2, or pi over 2, sorry. And again, that is the same thing as saying cosine pi over 2, because you reduce that. Anybody remembers how to reduce? 3 goes into 3 one time, 3 goes into 6 2 times, so 1 over 2, just 1/2. All right, so then cosine of pi over 2 is what? 0. Right. So here, 0 does not equal 1 plus the square root of 3 over 2. So therefore, this is a counterexample that this is not true. So this is not true, because we have a counterexample that shows that is not true for every value. And remember, if it's an identity, it works for every single value. All right, so that's part A. We verified it, say that they were not true. All right, so then for B, it says use the sum identity here for cosine, using the same values that we just used to prove that that is true. So we're going to use that in our trig identity. So here, again, we're doing cosine x plus y. Remember, for our cosines, the cosines stay together and the sines stay together. But then we just put the opposite sign here. So that just means it's going to be a subtraction right here. Okay, and then we also said that x was pi over 3. We said that y was pi over 6. And so all we're going to do is verify that both sides equal each other. And then we are good. We are good. And so if we do that part, let me move this down. Up. Oh, let me shrink it. No, I'm going to have to move it around because you won't be able to still see the work. So let me put it over here. Put it on top. This is what we said we're going to use. So here, we're going to make sure both sides equal each other. And if they do, that means that we're good with our identity. And all we're doing is substituting in for sine x and y. And again, we already said what x and y are. And why are we using these same ones again? Because it says to use the same values from A into B in the problem for B. All right, so again, if we multiply these, or add these two together, that would end up being pi over 2, as we just found out. So cosine pi over 2. And then each one of these we have values for. Well, first off, here, we know this is 0, because we actually worked that out on A. All right, so now each one of these has a value, and we already talked about the values for the cosine part already, because we just looked at that. And so we know here that when it comes to pi over 3, that's 1/2. For a cosine pi over 6, that's the square root of 3 over 2. All right, then we subtract. Sine of pi over 3 is square root of 3 over square root of 3 over 2. And then the sine of pi over 6 is 1/2. And so here, that's a square root of 3 over 4 for this part here. Minus, multiply again, straight across, a square root of 3 over 4. So we get 0 equals 0. So we have proved that this works for the values that we used in A. So that means that this actually is an identity because it works there. Okay, so as of right now, we've proved that it does work for the values that we used for A. But we also know from all the other stuff that the identity is true. All right, so that's it. Let's move on.